Hello everyone, welcome back to our channel Electro Study. This is lecture series 3 Embedded C Basic dealing with 8051 microcontroller. Come, let's go into the video. Please do like, share, subscribe and comment. So we all know about the microcontroller is heart of the embedded system. So one type of microcontroller we are going to see in this lecture series, that is 8051. This 8051 microcontroller, it was actually designed by Intel. It is an 8-bit microcontroller. It is an 8-bit microcontroller. You have 40 pins, which all those pins are dual in package. And the memory storage is 4 KB of ROM and 128 bytes of RAM. So these are the storage memory storages, and you have a timers which is 16-bit. So it is consisting of 8 ports, 8-bit ports, that is 4 ports, port 0, port 1, port 2, port 3. All these 4 ports will have 8 bits. So that will be either programmable or addressable. So based on our requirement, we can use it either to address or to program the data. And you have an oscillator, crystal oscillator, which is integrated across the microcontroller, and the frequency of the oscillator is 12 megahertz. So already we know that it is having a central processing unit. It is having interrupt control and 2 pins attached to it, that is external interrupts, int 0 and int 1. This pins will indicate the microcontroller about the high and low priority task. And you have on chip ROM, that is the memory, ROM and RAM, which is 4 KB and 128 bytes. And you have timers, timer 0 and timer 1, which is going to tell or count the minutes or seconds that one particular instruction is taking time to execute. And you have serial port where serial communication takes place, TXD and RXD, which is nothing but transmitting and receiving port. And you have 4 ports, which I have already told you, and bus control, which acts as a communication channel. This is the basic architecture. Then I'll be seeing about the memory organization. So you have internal and external memory and program memory too, which is RAM, ROM. It is classified as RAM and ROM. So generally, the 8051, you have memory organization where the limit of the internal memory will be around 4K. So the control will automatically get into external memory to fetch all the remaining instructions. That is how it plays a role. So when you see that 8051 is having some internal memory which is of 4K size, and it needs some external memory. So even though when there is an embedded memory in the microcontroller, we are in need of external memory to store the datas. So that is being interface, that is external program memory. So totally you can tell that it is having 64K size of memory. So when you can see that EA is equal to 0, this is nothing but EA is nothing but it is external access pin, where this external access pin, when it is connected to the VCC, that is voltage, the instruction will be fetched from the memory and executed. If it is made 0, then it is said that it is idle. There is no fetching of data from the memory. It has been idle. So if the programmer actually wants some data, then he or she fetches the instructions from external memory and then the internal memory. Then it is connected across this pin where it is connected to it is connected to ground. EA pin will be connected to ground, where you will be seeing about the pin diagram also in the next slide. So it will be connected where EA is equal to 0 is idle and EA is equal to VCC is nothing but it is connected across, there is a voltage passing across the EA where the datas are fetched. You have timers and counters. So these are some of the timers and counters that you can see. You have special registers for this, which is known as TMOD, TCON, TH0, TL0, TH1, TL1, and you have some where this timer pin acts as a counter for a particular port. All those are available. So here you can see timer is basically what I have told us. It will be counting the number of minutes or seconds an instruction takes to process the data. So if there is any delay in a particular time, that also will be indicated by the timer. So based on that, for example, I can tell you the LED street lights, where you have notice boards available attractively. You can design using LED. So based on the timers, the LED glowing will be differing. So that is all the timers work. And counters is nothing but it will count the number of events per cycle. So you have for counters, you have TMOD and TCON, that is timer mode register and timer control register, which will be controlling the instruction, and also it will be turning on the mode whether it is going to count or it doesn't. So this is how it works. And for timer, it is having a special 16-bit timers where the delay starts from 000 to FFF, that is lower bit to higher bit. And you have obviously two functional registers that we have already seen. And based on serial port and input output ports, here you can see that serial port is nothing but the TXD and RXD, which I have explained, that transmitting and receiving of data. And the special register allocated for serial port will be SCON. This is the one which will be controlling the operation. Input output ports, we know that there are four input output ports: P0, P1, P2 and P3. So now here you can clearly see in the pin diagram, this is port 1, this is port 3, this is port 2 and port 0. So you have other pins where you can read, write, timer pin, interrupt pin, then serial communication pin, EA is equal to 0. See here you have that memory to fetch the instruction. So you have different pins like that. So when seeing about your port 0, what happens in port 0 is, when the external memory is used, then some lower address bytes will be applied on it, because else all the bits of this ports will be configured as input or output. Say suppose if you are taking P0, that is all these port, that is P0 port. When P0 port is configured as an output, now you're configuring port 0 as an output, then what happens? Then all the other ports which is having its own particular pin will have an inbuilt pull up resistor across it, so by which all those will be connected to a 5-volt power supply, and the pins of that port have the resistor left out. So in port 1, what happens is, it also acts as an input and output port, but it doesn't alternatively function like how P0 functions, either as input or output. No, once specified, it will continue to do the same. And P2 port, it is nothing but, it is also similar to the P0 port, where external memory, so where this port will be used for addressing the bytes, where the address will range from A8 to A15. So when there is no memory that is added, then the complete port will be used as the input or output port, how the port 1 is being used. And this port 3, you have serial communication across it, timers, interrupts, read and write function, all those. So when you make all these pins logic 1, all these pin will do its function respectively. If it is made logic 0, then there is no reading of data, writing of data, no timers, no interrupts, no serial communication. So extal is nothing but the oscillators. Ground, you have VCC and ground. So this is the pin diagram of 8051. Hope you have understood this very clearly. Hope you have understood. Stay tuned for more information. Thank you.